And here we go. So this section is about functions. It's called operations of functions. We're gonna look on how you deal with the operations we're used to, so addition, multiplication, subtraction, and division, but when you are applying it to a whole function, or sometimes to a value in a specific function. So we call this algebra of functions, yes? So we're going to look at addition of functions, and if you're looking at the addition of functions, the notation is going to look like this. So let's call f and g normal functions of x. So instead of the usual notation where you see f of x and g of x, right? So it's a function of x, right? So this value right here is the unknown value of the variable x, and it's applied in the function. That's what this means, right? Well, here, instead of writing it like this, you're going to write both letters, the notation of the function. Oh, I think I got stuck. You're going to write both letters, which is the notation of the function, place them in parentheses, and then another teeny tiny pair of parentheses where you write the x, right? So I'm basically saying that this is a function where you have f plus g of the value x. See what I mean? So this is the addition between two functions, both of x. Subtraction is going to have a similar shape. It would look like this, s minus f minus g of x. And if you want to write it out, this basically means f of x plus g of x. And they both have the same value x, yeah? So they're both going to be to the same variable. All right? Now, multiplication looks exactly the same. See that? Dot? That's a multiplication. We usually avoid using x as a multiplication because it could be confused with the variable. And some people use this notation. I'm going to do it here. This notation as multiplication, right? The really crazy star. But it could also confuse you with x. So we just use dot. So if you see f dot g, this is a multiplication of the function f and g, all right? And this means f of x times g of x. Yeah. One last one. Division. So if you see f over g, like that, of x, that means you have f of x over g of x. Make sense? So f and g are both separate functions, but I'm not sorry. My mouth is not cooperating. Sorry. So f and g are functions of x, but they are being added, subtracted, multiplied, or divided based on the operation the question gives you. So whenever you see one of these, this is what I'm talking about. So when you see f plus g of x, I'm saying I want you to add the function f of x to the function g of x. And notice the order. So I have f plus g, so f goes first, g goes second. F minus g, f goes first, g goes second, and so on and so forth. You have to keep the order. Now, usually, the order doesn't matter for the addition and the multiplication because if you add them backwards, it still works. Multiply them backwards, it still works. But with the subtraction, it's really important because if you subtract g from f, you're going to end up with a different result. Does that make sense? So make sure to maintain the order you see in the operation. First letter goes first, second letter goes second. Yes? Same for the division. All right? So let me show you a few examples on these. Here you go. This is the first group of problems in the notes. Now, they all have the same given functions, so I'm going to write the functions first. So for these questions, you were given f of x to be this function, which is x squared minus 3x plus 1, right? Now, g of x is the root 8 minus x. Right? The whole thing under the root. And we have a third one, which is h of x. Okay, and h of x is 2 over x plus 1, which is a rational. So we have a quadratic, a radical, and a rational function. H is this, it's separate function, right? So f, g, and h. Now, number one's pretty easy. All I'm asking you to do is find f of -3. So what am I going to do? I'm basically telling you that x is -3, yes? So I'm going to plug this value in. And since the function I gave you is f, that means you are going to use this one. So that means this is -3 squared minus 3 times -3 plus 1, right? Which equals what? -3 squared is 9 positive, right? And then you have -3 times -3, which is positive 9 as well. Then plus 1, which totals to 19. Yeah? Okay. So that was easy. Second one is g of 4. So the x value in this case is what? It's 4. And the function I'm using is obviously g, so I'm gonna plug into that one. So you're gonna write down the root 8 minus 4 instead of the x. So plugged in the 4 right here. So you end up with root of 4, which is 2. There you go. Right. So far so good. Now this is basically a review because we've already seen this in functions. Yeah. So what about number 3? Can you guys do this one? I'm giving you f of a plus 1. Yes? So basically, I'm telling you what? That instead of x, you're supposed to plug in everything inside, which is a plus 1. So I'm going to plug this in into the function f. So how about I give you a minute to do that and tell me what you get. And remember, this replaces every single x in here. The a is just a number you don't know, so you don't need to worry about where it came from. The question simply asked you to plug in a plus 1 into the equation, or into the function. And we did a similar problem like this in section 2.1, I believe. Is where we introduced functions for the first time. And that one was 3 plus z, if I'm not wrong. Similar idea. So plug this in, everything you see between the parentheses, plug that in instead of every single x, and then simplify the function as much as you can, and tell me what the result is. All right, the mat is up. Let's look at it together. Here we go. So, do we all understand that this right here, a plus 1, replaces every single x? Yeah? So, grab the first x, which was squared. So, pair parentheses, a plus 1 goes in there, and then you square it, right? Minus 3 times. We have another x. So, you place a plus 1 in there, and the whole thing is multiplied by 3. And then plus 1. Yeah? Okay. So now we try to simplify this. This right here is a pair of parentheses multiplied together. So I'm going to do it on the side. You have a plus 1 times a plus 1. So, all right. So a times a is a squared. A times 1 is just a. Now 1 times a is another a, and 1 times 1 is 1. So you get what? A squared plus 2a plus 1. All right? So that replaces this one right here. So you place a squared plus 2a plus 1. Now minus this right here. We have the 3 times, or negative 3 times a plus 1. So negative 3 times a is negative 3a, and negative 3 times 1 is negative 3. And then you add the 1 at the end. All right. Now let's combine legs. We don't have any other a squared, so I'm going to place that as it is. Now, a, we have a positive 2a and a negative 3a. That leaves you with a negative 1a. So negative a. So we did this one, these two. Yeah? That leaves me with what? A positive 1, and a negative 3, which leaves you with another negative 1. And that will be the final result. See? Make sure you choose the correct functions. And I'm sorry if my handwriting made it look like an H. I don't know. But this is an F. Yeah? Okay. Now, let's start playing with these a little. I'm going to skip number 4 because it's a similar idea. And I'm going to go to number 5. Okay. So 5 says what? 5 is asking you to find f minus g of negative 8. So what does that mean? I'm asking you to subtract the two functions of this value. Yeah? So what I'm going to do is I'm going to plug the negative 8 into f and g, and then subtract the two from each other. Make sense? So first we start with the first one. So f goes first. You grab this and you plug in negative 8 for every x. So we have negative 8 squared minus 3 times another negative 8, and then plus 1. That's my first function. Okay? Second function, minus. Now, you don't need to in this case because it's a root, but I recommend every single time you want to do this, when you have subtraction of functions, before you start writing the second function, always place a pair of parentheses, because that will prevent you from forgetting to multiply the negative in. Does that make sense? Always do this. You don't need to worry about it in this case because we have a root, but usually this is important to do. Okay, this is a good idea to do. So yeah, we're skipping number 4 because it's simply plugging 10 into g. Yeah. Okay, so make sure to start a pair of parentheses before you write the second function every time. Even if you don't think it's necessary, just do it. That way you get used to doing it and you won't forget. Okay, so now we're going to plug in g. Okay, so it's root of 8 minus. Instead of x, I'm placing negative 8. So it's minus negative 8. Okay, which makes both of them positive. Close it, the pair of parentheses. All right. Now, negative 8 squared is what? What's 8 squared? It's 64. Minus, or actually it's going to be positive because you have 3 and 8 and they're both negative. So plus 3 times 8 is positive 24 plus 1. So these are the numbers here. Minus, now we have root of 8 plus 8, which is 16. And I'm subtracting, right? Okay. So now let's add these. We have what? 64, 24, 1, and under the root of 16 is actually 4. So I'm subtracting 4. That adds up to 85. Right? So that's our answer. F minus g of negative 8 is 85. Okay, let's do another one. How about number 6? We have g times h of 0. So again, you write the first one first, second one second, and we plug in 0 instead of every x we have for both. So I'm going to go down a little so we can see the functions again. Okay, we're using g and h. So these two, g and h. Start with g, which is root of 8 minus x. So I'm going to write the root. I'm going to do this, trying to get everything to fit, I suppose. So root of 8 minus, instead of x, it's 0. So that was g. Now, times. Let's look at what h is. H is 2 over x plus 1. Okay, so here I come, right? 2 over, instead of x, it's 0 plus 1. Yeah, so every x got replaced by the 0 over here. All right, so 8 minus 0 is just 8. So we have root of 8 times 2, because 0 plus 1 is 1. 2 over 1 is 2. So it's 2 root of 8. So you can rewrite this as 2 times square root of 8. You can simplify square root of 8 a little bit, because this is actually square root of 4 times 2, right? And a multiplication under the root with no other additions, then you get root of 4 times root of 2. You can split this. And root of 4 is a 2. So 2 times root of 2. And obviously these two combine and you get 4 times root of 2. This is the simplest answer. Now, in the homework, if they don't accept you to, if they won't accept an answer in root form, they might ask you to enter decimals. So pay attention to the instruction. It could say to go to the round up to the highest 2 decimals or 3 decimals or whatever they ask you to. All right. Let me show you another example. How about the next set? Let's look at these right here. Now, here we have a slightly different question. Yes? Instead of asking you to find or evaluate what is going to be at specific values, it's asking you to find the domain of the functions. So, first one is s of x, and we have 2 over x. Second one, we have t of x, and it is x plus 4. And the third one, we have r of x, and this one is x squared plus 3. Okay, so we have a linear, quadratic, and a rational. So, question number 8 says what? It's asking you to find the domain of r minus t of x. Notice I didn't give you a number. So since I didn't give you a number to plug in here, that means that you're just gonna solve for x. So this right here is basically r of x minus t of x, and give me the final result. Once you do, then we look at what that is and find the domain of it. Okay, so we're subtracting r and then t. So r goes first. We have x squared plus 3. That's my r. So x squared plus 3 minus parenthesis t, which is x plus 4. Now in this one, the parentheses plus. because now you can notice that this negative is going to turn the x negative and the 4 negative. Yes? So multiply the negative in, you get what? X squared plus 3 minus x and minus 4. That is x squared minus x, positive 3 and negative 4 is negative 1. That's my function. This right here is a quadratic. And a quadratic has a domain of negative infinity to positive infinity. There are no limitations here. So it's your domain. It's a polynomial. Any questions? No? Okay. Are you still there? Just to make sure I didn't cut off.
Still here.
Awesome. Okay. Good. Okay. Let's do number 9. This one's going to be a little bit more fun. We have a division. So 9 says you have r over t of x. Okay? So I'm dividing r and t. R on top, t on the bottom. And since I gave you of x, that means you don't have a number to worry about. So we grab r first, which is x squared plus 3, and t, and place it on the bottom, which is x plus 4. Now, what would be the domain for this function? There's no more simplification you can do here. So this is as far as we can go. When it comes to rational functions, what was the rule? There's a value that we need to exclude from the answer. Like it cannot be the answer for the rational function. It cannot be in your domain. And that would be whatever value that turns the denominator to 0, because the denominator can never be 0. So what you're going to do is grab the value on the bottom, all of it, which is x plus 4, and you set it equal to 0, and then you solve for 0, or for x. So I'm going to grab the 4, move it to the opposite side. It turns negative, and you get x equals negative 4. This right here cannot be included, which means my domain, as far as this one's concerned, starts at negative infinity, goes all the way to what value? Negative 4. Stops at 4. Now am I going to use a parenthesis or a bracket here? Now, since I said it cannot equal negative 4, that means it's a parenthesis. If you use a bracket, that means you're including negative 4, and that defeats the purpose. We don't want it to be in the domain. So it's a parenthesis. And then you use union, another parenthesis, start at negative 4, and it goes all the way to positive infinity. Yes? Okay. Now let's do the last one, number 10. And this one's asking you to do what? Find s times t of x. So multiplication between s and t. Let's go back up just to take a look at what they are. So s is 2 over x. Yeah? And since, again, the question told you of x, and I just gave you x, that means you don't have to plug in any other numbers. So I'm going to write 2 of x here, and then times. Now, as we saw from previous examples, t is x plus 4. X plus 4. So this is s times t. Okay? Now, I did this because I wanted to see that 2 over x is multiplied by the x and the 4, not just the x. So it's always a good idea to place a second function. Whatever the operation, you place it in parentheses. Okay? Now, this equals what? I'm going to multiply 2 over x inside. to both values. So you get 2x over x plus 8 over x. Yeah? Which is basically 2x plus 8 over x. Now, this right here is my function. Now, if you saw this, and instead of writing that, you thought this x cancels with that x, and that gives us, so this is another alternative, that gives us 2 plus 8 over x. That's also correct. That's fine. It's the same result. Now, what is the domain of this function? Right here. Again, this is a rational function, and a rational function has one value that you need to avoid. In this case, it's what? Can someone tell me just by looking at this? Because again, we're going to grab the denominator and set it equal to 0, and then solve for x. So what's the value I'm trying to avoid? X cannot equal what? 0, yes, because there's no solving here. When you place x equals 0, you're done. There's nothing to move, nothing to do. Make sense? So it's already clear. It's 0. You cannot have 0. Over here, let's do that so it's clearer in the video. Yes? So the answer cannot be 0 no matter what. That value cannot be in your domain, which is true here as well. Where do you have an x? Right here, and it's in the bottom. Therefore, x cannot be 0 for this function. So the domain would what? Start at negative infinity, because all the other values are fine. The only one we have an issue with is 0. And it will go all the way to 0, and then we're going to place a parenthesis. 0 is not going to be included. Union, another parenthesis. Start again at 0, and it goes all the way to positive infinity. Now, is it clear to everybody why does the intervals here cut off at the value 0, but I'm still placing 0 at the end of both intervals? It's because on this side, the numbers clear or close to 0 from the negative side could be negative 0.000000001. That's so close to 0, it's almost 0, but not quite. This way, you're including it. On that side, same thing happens, but on the positive side. Writing it like this only serves the purpose that you're excluding the one value 0 and nothing else. Make sense? So on the graph, if you're graphing this, you will end up with one hollow point. Yes, you're going to end up with something that looks like this. Yeah, one hollow point. At 0, you're going to have an empty point. That's what that means. Okay? So we're getting a review for the other stuff we took as well in this section, which is kind of cool. All right. Now I want to show you something called the difference quotient. Let me remove this page. Okay. And oops. Here we go. So difference quotient is the idea where the secant line intersects a function and you're trying to find the difference of that function. So it's very similar to the idea of slope. So if you remember slope, we said it was delta y over delta x, right? Okay, so to do the difference quotient, you're going to draw on the same idea here. So instead of it being y2 minus y1 over x2 minus x1, we're going to write it in the form of f of x plus h minus f of x over x plus h minus x. Yeah, so instead of it being f of x2 minus f of x1 over x2 minus x1, I wrote x2 in the form of x1 plus a number, because that's what it is. For example, if the 2 points I was talking about for x were the points 1 and 2, then this would be 1, and that would be 1 plus 1 to make it 2. Make sense? So you're writing the x as the same variable x. That's the purpose here. Instead of having two unknowns, which is x1 and x2, the one unknown, which is x. We also have h, but that's supposed to be a number. Make sense? So we have f of x plus h minus f of x over x plus h minus x. So this serves to be x2, and that's your x1. And f of x2 would be your y2, f of x1 would be your y1. So it's the same idea as slope. Now, there's a further simplification we can do here. It's because you have x and a negative x. So this simplifies to be f of x plus h minus f of x over h. And just a little hint, if you're planning to take calculus in the future, this right here is a definition of derivatives. Take the limit as h goes to 0, and this will be the derivative, or at least the intro to it anyway. It's a definition of derivatives, because later on you'll find an easier way to take derivatives, but that's not for you guys. It's just a cool tip for the future. Anywho, so this right here, like I said, is called the difference quotient. All right. Now, let's look at an example and see why this is so useful. If I'm going to give you a question like this on the test, it will be in the form of number 11, number 12. For example, question says, find f of x plus h, which is the second value, and f of x plus h minus f of x over h for this function right here, which is f of x equals 5x minus 2. So it's number 11. So what the question is asking is that I want you to use this function right here to first do what? Find this one. So you're going to plug in, so the first purpose, let's call it A, find f of x plus h. Oh, I lagged. Is it still lagging? This looks okay now. Okay. So first step, find f of x plus h itself. So I'm gonna plug this in instead of x. So over here we have what? 5 times x plus h. Yes, minus 2. There, done. We replaced every x with x plus h. So that was finding f of x plus h. All right, oops. Now I need to use this here. So the second part, they want you to find the difference quotient. So we're going to calculate. F of x plus h is this right here. So I'm going to write it down, which is 5 times x plus h minus 2. And then minus. And then comes the actual function. Use parentheses. I'm going to use this right here, which is 5x minus 2. Notice the parentheses to make sure you distribute the negative. All right. Now this whole thing is going to be divided by what? By h. So I'm dividing all of it by h. And then you solve. So I'm going to do it here. Now here's a trick. You want to get rid of the h. So let's do that. First, try to open everything up. Let's get rid of the complications. So I have two pairs of parentheses here. I want to get rid of them. Let's start with this one. We have 5 multiplied by x plus h. So I'm going to multiply this 5 in, like that. So you get 5x plus 5h. Okay? Minus 2. And then minus 5x plus 2. Whole thing goes over h. G equals. Okay. Now I have 5x over here and negative 5x over here. They add up to 0, so these cancel. Yes. And I have a negative 2 and a positive 2. They also add up to 0, so they cancel, which leaves us with 5h on top. So the final result is 5h over h. Now top and bottom, we have h over h, so they cancel, and that leaves you here with a 1. So that's 5 over 1, and the answer is 5. So this right here is a difference quotient. The answer is 5. Now, usually I tend to not bring this on the test. I have before, but only once or twice, and not on the final. That said, I always like to show you the difference quotient because, like I said, it will be very helpful if you plan to keep going in math classes and take pre-calculus and calculus, because you will see this fact again. It would just be the limit of that. All right? Okay. So I'm going to skip number 12 and move on to another fun part of the section, which is actually my favorite. It's called composition. If you remember, at the beginning of class, I talked about the 4 operations and how we are going to apply them to functions instead of simple numbers in this section, right? I'm going to use operations on functions. And we saw addition, subtraction, multiplication, and division. Well, now I'm going to show you a new one that only applies to function, and it's called composition. Yes? So this is the 5th operation to the first 4 I mentioned, which is composition. Now, how does this work? The notation for compositions tend to confuse students. They usually mix it up with multiplication because they look very similar. This is the notation you're going to see. If we're still using the same 2 functions, f and g, it's going to be f and then a little circle, g of x. So it looks like fog. Yeah? Multiplication with a dot. It's not the same thing. On tests, make sure it's not a dot, that's a circle, or not a circle, it's a dot. And if it's not clear, ask me. But it should be clear, very clear, because, circle is not the same thing as a dot. So when you see fog or goff, if I decided to give it to you backwards, this is composition. If the middle looks like an O, it's a composition. Yes? And like the other operations, the order matters. Now, the one that comes first goes on the outside. The one that comes second goes on the inside. Because the idea of composition is that you're plugging in one function into the other one. Yes? So I'm saying the composition of f and g, that means that I want you to write f of g of x. That means you're going to grab the second function, which is g of x, and plug it into f of x. So replace the x of f of x with the whole g of x function. Make sense? And again, the one on the outside is the one that comes first. The one on the inside is the one that comes second. So if I gave it to you as fog, this is what you do. If it was goff, it's going to be g of f of x. Yes? So this right here is the fifth operation, and it's composition. Now, let's try a few. Here is example number 13. So in this one, it says that the two functions that you're going to play with are f of x, and it equals x squared minus 3x plus 1, the same f of x function we saw at the beginning. And the g of x you're going to play with is 5x plus 4. Yeah? So these are my two functions. Now, I want you to give me the composition of f and g and x. So it's fog. F was written first, so g comes second. Now there's two ways to do this. You can do both operations at once, or you can do them one at a time. Both are correct, and both will give you the same result. So I'm going to do both. That one looks like this. You write the f of x function, which is x squared negative 3x and plus 1. So you have two x's here that you need to change. So I'm going to write parentheses with a big space in between, squared instead of the first one, minus 3 times another big pair of parentheses, plus 1. So if you see, what I did here was write f of x. This is the function f of x. I just left the value of x itself blank. And I left enough room because I know I'm going to plug this whole thing in here. Yes, because g goes in. So we have 5x plus 4 in here, and 5x plus 4 in here. Okay? So now we have one of them being squared. So that is what? 5x plus 4 times 5x plus 4. Now, here's a shorthand for when something is squared. I usually do it by hand in lecture because I want you guys to get used to the idea. But a shorthand to this is when you have a plus b squared, like this. This equals a squared, so you grab the first one, you square it, plus 2 times a times b. So you're going to multiply these two numbers, a and b, and then multiply by 2. Because that's what happens. You multiply a by b the first time, and then you multiply this b by the other a the second time. Make sense? So you're going to do this multiplication twice. So 2ab plus b always. If you have bare parentheses of two values added, subtracted, whatever, it's going to be this right here. Okay? So if it's a negative, then it's going to be a negative right here. These are always going to be positive because you're squaring them. Okay? Now, let's use that here. So we have 5x squared. And 5 itself is going to get squared, so it's going to be 25 x squared. And then I'm going to have 5 and 4 multiplied together. That's 20x times 2, 40x. And then 4 squared is 16. Yeah, so that is the first one. Now, negative 3 multiplied by everything in here gives you what? Negative 3 times 5 is negative 15. So it's negative 15x. And then negative 3 times the 4 is negative 12. And finally, you add the 1. All right. Now let's combine legs. Nothing else is squared, so 25x squared stays the same. Now we have positive 40x and then negative 15x. So if you subtract these two from each other, that gives you a positive 25. Positive 25x. And I used this one and that one already. Okay, that leaves me with the numbers. So we have positive 16, negative 12, subtraction between these two leaves you with a positive 4, plus 1, and that's a positive 5. And that's your answer. So you grab the first function, the one on the outside, write it down with the x places blank. You grab the second one and you place it in here, and then you solve. Okay? Now, this is the method that's always going to work. If you remember, I said there's two ways. If I give you a question where you have a composition of two functions and I give you an x in here, then this is the one you're going to use, always. The second way only works if I give you a number in here. For example, instead of it being x, this is not in the notes, but just to show you the possibility. Let me do this. Keep this in my note. Anyway, so if I set composition of f and g, oh, we said it's not going to be x. Okay, let's make it 8. Of 8, yes? So now it's a number. It's 8. All right. So instead of doing it this way, which, like I said, always works, you're going to do it the second way. Now, the second way is basically that you're going to do them one at a time. Yes? Because this right here is the composition of f of g of 8. Right? So first step, you're going to find what g of 8 is. So I'm going to grab g, is 5 times, plug in the 8, plus 4. This is 40, plus 4 is 44, right? Okay. Now, you use that to plug in here. 2, you find f of 44. Now, why is it f of 44? Because 44 is g of 8, and I'm trying to find f of g of 8. Make sense? So you're going to plug in that value in here, and you find f. So I go to the function that was f right here. So I have 44 squared minus 3 times 44 plus 1. Oops. Okay. Now, 44 squared is what? I actually don't know what that answer is. So 44 squared, let me see the calculator. Oh, big one. 1,936 minus 44 times 3. So it's going to be negative 132. And then plus 1. So if I want to do the operations, that gives you 1,805. And that's your answer. So this was the two-step way. First, you find the one on the inside, and then you plug it into the one on the outside. Easy. Now, when I give you a number in here, you can still use the way I showed you above. It would look like this. So it would be f of, of 8. So you go, okay, so I have 5 times 8 plus 4. So this is g of 8 squared minus 3 times 5 times 8 plus 4 plus 1. And then you solve. Make sense? But like I said, this way is only possible if I give you a number. Because think about it. If you want to use this with a question where I'm asking you to find the composition of two functions and I give you x, then in here, you're not going to have g of 8, you're going to have g of x, and you already know what g of x is. So there's nothing for you to do, really. You just need to plug it in. Make sense? So that step is irrelevant. This is what you're doing right away. And it is the function itself. So what you're doing here is inevitable. Make sense? So this is only possible if I give you a number. And it makes things easier. Or I should say less complicated. Because this is just as easy and you can just plug it into the calculator anyway. All right? But it's up to you which one you use. Okay, now let's move on to a different example. The more practice you get on these, the better. Here you go. Let's play with another two functions. Okay, how about number 14 this time? So we're going to do 14. We have f of x, which is 5x squared minus 1, and g of x, which is the root of 5x plus 5, all of it under the root. All right? Now, I want you to give me, let's do the opposite this time. Actually, let's do both. I'm going to do both. I'm going to find the composition of G and F, right? So G is going to be an F. And the composition of F and G, but I'm going to write that in a minute. So let's start with this one. F is on the outside. So that is 5 times this whole function right here, root of 5x plus 5, and then it's squared, that's your x, and then minus 1. So correct. When you square a root, the root disappears, correct? So this cancels with the 2 over here. And you end up with what? 5 times 5x plus 5 minus 1. Okay. So 5 times 5x is 25x. And 5 times 5 is 25 minus 1. These add up to 24. So you have 25x minus 24. So that's the answer for the composition of G and F. Right? So follow. Now let's do F and G, which is golf. It's not really a word, but whatever. Golf. Yeah? So now I'm going to place F inside of G. So G is going to be on the outside. I'm going to write G first. Root of 5 times. Now instead of the x value, I'm placing all of this, which is 5x squared minus 1. Yes? Close the parenthesis. That was your x. Now plus 5. All under the root. Okay. Now we calculate. So we have what? Let's see. You have 5 times the spare parentheses, so let's multiply it in. And remember to keep your root. So you have 5 times 5, which is 25x squared. Yes? 5 times the negative 1 is negative 5 plus 5. These two add up to 0. Negative 5 and positive 5 is 0. So that gives you what? Root of 25x squared. Now this is a value you actually can take a square root of, because 25 is 5 squared, and x squared is obviously being squared. So this equals 5x. That's your answer. Now both gave you neat answers, which is awesome, but note that they are different. Yes? So it's not the same thing. You always need to pay attention to the order. If the question gave it to you like this, F goes first. If it gives you like that, G goes first. And F is inside. Any questions? All right, I'm going to take it as a no. Awesome. Okay. Let me see. All right, so number 15, let's play a game. For number 15, I want you guys to try this on your own. Here you go. F of x is what? 3 over x minus 4. Yes. And g of x is 2x minus 8. Okay. Now I want you to give me what would be the result of composition of G and F of the value 9? So I'll give you a number this time. Yes? 9. And composition of F and G of the value 6. Just for fun. I flipped those, so I flipped the number. Okay? So I'm gonna give you 5 minutes for each. So 5 minutes, and then we'll do this one together. Another 5 minutes, and we'll do that one together. I'm gonna mute my mic while you guys think about it. Alright, you guys, let's try it together. Here we go. So, for the first one, it's a composition of F and G, where G is going to be inside of F, yes? So we have, I'm going to write that first, And that is 3 over x, which I still don't know, of g, yes? So, big parentheses for x, and then minus 4. I'm going to extend this to be really long. Okay. Now, 2x, oops, instead of x, I'm supposed to enter 9. So 2 times 9 minus 8 goes in here. So 2 times 9 is what? 18, right? Minus 8 makes it 10. Okay. So 10 minus 4 is 6. So that equals 3 over 6, which is 1/2. First one is 1/2. So let's do the second one. Actually, I said I'd give you 5 minutes for that one too. So let me wait another 5 minutes. While we do that, does anybody have a question about this one? Did everybody get it? How I got the 6? All right, awesome. Okay. Give me another 5 minutes. I'm gonna mute my mic so you can. Did someone raise their hand? I think I heard it. No. Okay. Okay, is everyone ready? Yeah? -5? That's right. So since I did this in the one-step way, I'm going to do this in the two-step way. Okay? So first, since it's composition of f and g, first thing I'm going to find is what? Since this is f of 6 inside g, right? So first I'm going to find f of 6. That we have an example of both ways. Okay, so f of 6 is what? Looking here, you have 3 over 6 minus 4. So this is 2, right? So it's 3 over 2. The answer. 3 over 2. Now, number 2, I'm going to find g of the answer of that, because this is what f of 6 was, correct? So it's going to be g of 3 over 2. So I'm going to plug 3 over 2 into this function now. So it's 2 times 3 over 2 minus 8. Okay, when you multiply 2 here, this 2 and that 2 are going to cancel. And you end up with 3. So it's 3 minus 8, which is -5. Yeah? Any questions? Okay. So next part is really fun. So this one's kind of like a game.
Wait, can you rewrite the page, please?
Oh, sure. This part? The bottom?
Yeah, just give me 1 second.
No problem.
Okay, you can change it now.
Okay. So now we will look at the next example. And then this one, I'm actually going to show you the piece of paper in the notes, yeah, to make it easier on us. We're going to do number 17, 18, and 19. So, oops, let me see if I can zoom in a little more. Okay. That's focus. Awesome. Okay, so let's read the question together. Number 17 says, given h of x is root of 3x minus 7, find two functions f and g such that h of x equals the composition of g and f. So this is a fun one. It's kind of like a puzzle. We're doing it backwards this time. Before, we used to do what? I used to give you f, and I give you g, and I ask you to find with this, whatever this is, right? But this time, I'm telling you that the composition is what I already gave you. So I gave you the composition already. Tell me what these two functions are. Now, the cool part about this problem is that there are so many solutions possible for this. It could be literally a number of functions that could give you this combination. So can someone give me one possibility? What do you think f and g could be? Because remember, we are plugging one into the other. Okay, what do you mean one? Okay, x plus 2. So x plus 2 is which function, and what would the other one be? I'll let you think about that for a minute. Now remember, I'm saying h of x is the root of 3x minus 7, and this right here equals the composition of f and g. So this is the same thing as g of x inside f of x. Now I'm asking you to tell me what is f of x and what is g of x. X squared plus 5x plus 2. Okay, but how would that lead you to root of 3x minus 7? Okay, let me give you one example. This is one answer possibility. There could be so many more. Let's see. Root of 2x minus 6 and x minus 1. Okay, so which one is which? Mark, you're saying f is square root of 2x minus 6? And this is x minus 1? Yeah? Okay. So if that was the case, let's work it out. I'm going to use a blank piece of paper. Okay? So if that was the case, we say that f of x is square root of 2x minus 6, yeah, and g of x is x minus 1, that's what you said? Okay, so the composition of these two is going to look like this. Let's do it together. So I'm plugging one into the other, correct? So we have root of 2 times, all this goes instead of the x. 2 times x minus 1 minus 6. So it gives you 2x, and then negative 2, and then negative 6, which is root of 2x minus 8. So that's not the same thing as 3x minus 7. But you're starting to get the idea. Yeah. So now try to work it backwards, because you guys are trying to think of what these could be and then putting them together and see if they're right or wrong. Grab this and work it backwards and see what that gives you. And there's an easy way to look at this. Now, there's so many possibilities. It's like it's not funny. But some of them are so straightforward. It's like, I can't believe I didn't think of it kind of straightforward. It's so simple. For example, let me give you one. What if I told you f of x is square root of 3x minus 7, and g of x was x? You see this? So if I plug in g of x into f of x, the x is going to get replaced with what? With x. No change. Done. That's the result. Let me show it to you. Of x, right? So this is going to be root of 3x minus 7. Same answer. We're done. Wasn't that easy? That was one possibility. There's so many. Another one could be that f of x is x. Oh, sorry, root of x. And g of x, yeah, g of x itself is 3x minus 7. So when you plug them in, this x is going to get replaced with this whole thing. So the final result ends up being what? Root of everything here, which is 3x minus 7. I wrote on the other page. That was another possibility. Can you guys give me one more? There's literally so many. You could undo or flip this possibility. If I do f of x to be x and g of x to be root of 3x minus 7. Like, but wait, how would that work? Well, easy, because you're replacing this x with the entire g of x. So this will disappear, and you write this one down instead. So the composition between the two is what? Instead of the x of f, I'm going to place a big parenthesis, and you're plugging in root of 3x minus 7. So the final result is root of 3x minus 7. See how fun that was? That's why I like this part. Like, you can give me so many answers, and you can still be right. Super easy. Now, I see that Mark gave me another one. You have root of 3x and x minus 7. Okay, let's try it. You said f of x, I'm assuming, right? First one is f of x. Root of 3x, yeah. And g of x is x minus 7. Well, let's look at it. This is composition, yes, of x. And x is root of 3 times something, and that something is x minus 7. See, we're so close. But the 3 is going to get multiplied to the 7 too. So you get what? 3x and negative 21. Yeah. There you go. Okay. So we already gave so many possibilities for this one, but let's stick with one. Let's say root of 3x minus 7 here, and this one's just x. Okay? Okay. Let's do 18. So I'm going to give you a few minutes to think about this one too. Tell me what you think. H of x is x plus 1 cubed plus 8. Can you tell me what f and g are? And for this one, there's also one very clear possibility, because you have the form of x plus 1 inside the pair of parentheses. That should give you a hint. So what could the two functions be? Again, it's composition of g and f. So The one on the outside needs to be f. Okay. F is 8x minus x plus 8, and g is x plus 1 cubed. Okay. Let's do this. Let's test it out. We said f is x plus 8. Yeah. And g is x plus 1 cubed. So the composition of these two would look like this. So I'm plugging g and f, yes? So instead of this x, I'm placing this whole thing. So it's x plus 1 cubed plus 8. Does it match? Yes, it does. That's one possibility. Anything else? Yeah, there you go. And there's, like I said, there's so many. The very straightforward one. You could easily say f of x is this whole thing. Yeah? So it's x plus 1 cubed plus 8 because we don't have any other x's anywhere else. And I could say that g is simply x. So when you plug it in, the x replaces the x, and that's it. Nothing else to worry about. Make sense? So that goes here, and the final result will still be the function you started with. That's always one possible answer. Another one that's really clear for this one, and that's the one I'm going to write on the page. Let's say f of x was x cubed. Yeah? Plus 8. And g of x was x plus 1. So if you plug in x plus 1, it gives you x plus 1 cubed, since the x was cubed, and then plus 8. Right? So many possibilities, but we'll stick with one solution. All right. How about number 19? This one's going to be fun too. Let's take a look. Here the question says, estimate the function values from the graph. So didn't give you an equation, but I did give you operations here. And I want you to give me the answer by looking at the graph. So let's do the first one. And we have about 5 minutes left in class. So let's try to do it quick. There you go. First one is 5 minus g of 3. Yes? So here's your f, here's your g, and it's of 3, right? So this equals f of 3 minus g of 3. Okay, so what's your f of 3? Where's f of 3? This is the point 3 for x. F is all the way over here, which is 4. So that's at 4. Minus g at 3. G is over here, which is 3. And the answer is 1. When you subtract, you get 1. Easy peasy. Let's do another one. How about this one? So it's g over f, yes, of negative 2. So we have g of negative 2 over f of negative 2. Yeah? Okay. G of negative 2 was the negative 2 for x right here. G is all the way over here, which is negative 4. So it's negative 4 on top. And f of negative 2, at negative 2, f is right here, which is positive 2. So the answer is going to be negative 4 over 2, which is negative 2. Awesome. Okay. How about this one? Now we have composition. We have composition of f and g of 1. So this is g of f of 1. Yes? So first we need to find f of 1, which is what? Where's 1? 1's right here. F is going to be over here, which is 2. So this is g of 2 now, since f of 1 is 2. G of 2, the x is 2 is right here. G is all the way over here, which is at the value of 4. So the answer is 4. Now, this is going to be the same way, so I'm going to skip it. Let's do that one because we have the same function. We have composition of f in f. Sorry about this one. So this is f in f, and it's of -3. Okay. So f of -3 is where? -3 for x is 1, 2, 3. It's right here, and it's 0. So this equals f of 0, since f of -3 is 0. Now we look for f of 0, which is right here, and the value is 2. So the answer is 2. Yeah? Does anybody have any questions? I hope you had fun. I like this section. Okay, let me take roll real quick before everybody leaves. And oops, and you guys are free to go. Hope you have a great weekend, and I'll talk to you later. Bye, everyone.